Okay, so I want to talk a little bit about amplifiers. So basically in this class, we're learning all about how to build, analyze, and design simple amplifiers. So first of all, what is an amplifier and why is it so important? So you can kind of see here from Wikipedia that it says that an amplifier is an electronic device that can increase the power of a signal. Okay, so basically it uses electrical power from a power supply to increase the amplitude of a signal applied. Okay, so an amplifier takes a small signal and makes it larger from an amplifier. Okay, so why do we care about this? What are some applications? Well, there's a lot. All the cool new applications all use some form of amplifier. So let's go and look at some cool stuff. So let's start here by looking at displays.
Far more vibrant as well. This thing is thin. It is crazy thin. Let me show you the side of it here. That pen is what? Twice as thick as the TV? It's on.
Okay, so here's an example of a very small, thin TV. So what does it take to make a display? So in order to make a display, you have to have some type of amplifiers to amplify the signal. You have to get the signal from your computer up to the display, and so there's all sorts of different things related to displays that all require miniaturizing amplifiers. Well, here's something on robotics. And so here we can watch this robotics
and the better of a player you are and the more challenging you are, the more challenging it gets in return. There was also a flexible tablet.
Okay, so you can kind of see this is talking about robotics, and robotics have sensors to read positions, and all those require amplifiers. You have motors to drive things and move things, and all those require amplifiers. Here's something on LiDAR, which is the essence of autonomous vehicles.
As you can see here, the single light photon is emitted from the sensor, hits an object like a tree, and bounces back to the LiDAR sensor, at which point the data from the light photon's travels is recorded. It is measuring distance and time.
Okay, so in this LiDAR application, you can kind of see that a light goes out, hits something, and that light basically scatters everywhere, and you pick up a very small amount of it, and you have it kind of going out of the narrow pulse and coming back and timing, and all that requires lots of amplifiers. So the amount of light that you're going to receive back by sending out a small pulse and then letting it scatter everywhere is going to need really good amplifiers. So the better your amplifiers are, the better your LiDAR systems are. Okay, so here is a camera. Okay, so a camera has to be able to process the things that it sees with the photodetectors and all of that. And so we kind of can come in here and look at this. So here's a small camera. So you can kind of see that thing is tiny, tiny, using for medical stuff inside. And so again, it's all about the electronics. Again, each pixel is going to need some type of amplifier. How do we make it faster and small to get everything to work? Here's some
video. The lighting kit we used includes loads of Roby fixtures. We've got pointies, Robin 100s, MMX spots, MMX washes. We've got some Elation Sniper 2Rs in there. We've got some Verilight.
So you can kind of see everything from audio amplifying to lights and motion. All of that is all related to the need for amplifier. Okay, so So you can see in this application, there's basically a car going over a pothole. When the wheel starts to drop down, it senses that very small motion and lifts the wheel up. So the car can drive directly over a pot wheel, and it's using the other three wheels. So the amount of amplifiers in order to do that, you have all of the sensors, the motor control, all of that. Here is a plot of the cars and the percentage of the cars, the cost of the car that goes into electronics. So you can kind of see back in the 1960s, there's like 2%. So you got like a ignition and a battery, and then that's pretty much it. Then we go to electronic fuel injections, airbags, electronics. You can kind of see they're estimating by 2030 that over half of the total cost of a car is going to be in electronics. So you can kind of see that the need for electronics, and a lot of that electronics, a lot of it's digital stuff, but there's a lot in amplifiers and sensors and all of that. And why would you want to do that? If you look here, this is kind of showing a plot of, the amount of deaths per mile driven. And so you can kind of see that it basically just goes down and down and down. And so the cars are way more safe today than they used to be. Some of that is mechanical, building good frames, but a lot of it is just airbags and electronics and everything. So you can kind of see that electronics are the key to what we're doing. And the key to electronics is amplifiers. And in this class, we're going to be covering how to design amplifiers. Now, obviously, we're not going to be designing these super fancy, super small amplifiers, but we're going to be learning about the principles of transistors